Welcome to the subject Electrodynamics 2. In this lecture, we will solve the problem 5.7. Dear students, your assignment is problem 5.12. Statement of problem 5.7 is, for a configuration of charges and currents confined within the volume V, show that integral V j d tau is equal to dp over dt, where p is the total dipole moment. In the third chapter, we have studied this definition of the dipole. Dipole moment of any dipole is defined as integral r prime rho r prime theta prime. What is the r prime? R prime is the position of the source points, and rho r prime is the charge density and volume charge density, and theta prime is the small volume element of source points. Let's start from the right side of the equation. dp over dt is equal to d over dt integral rho r theta. We have put the value of the p here, which is equal to integral rho r theta is equal to dt और d over dt को हम इंटीग्रल के अंदर लेके आए हैं, तो इस तरह से हमारे पास ये बन गया इंटीग्रल कर्ली रो ओवर कर्ली t r theta. And in the previous lecture we have studied the continuity equation. Del dot j is equal to minus rho over t. Putting the value of curly rho over curly t here, and its value is equal to minus del dot j. So dp over dt is equal to minus integral del dot j r theta. We are using to evaluate this expression. We are using this product rule here. To solve this, first we take the x component of dp over dt. What will be the x component? X component will be integral del dot j. X component of r is x theta. So first we solve del dot j x theta, and then similarly we will solve for y component, mean y here and z here, and then we will combine all these components to get whole dp over dt. Using this product rule, we can write divergence of xj is equal to x divergence of j plus j gradient of x. Here x is a scalar quantity and j current density is a vector quantity, and using this product rule, scalar quantity is left as it is. X divergence of vector quantity plus vector quantity dot divergence of some scalar function. So gradient of is scalar function. What is the gradient of x here? Because gradient is defined as curly over curly x cap plus curly over curly y into y cap plus curly over curly z into z cap. If we take the gradient of x, it would become curly x over curly x is equal to 1 into x cap. So gradient of x is equal to x cap. Divergence of xj is equal to x divergence of j, and putting the value of del x is equal to x cap in this second term plus j dot x cap. So we can write j dot x cap jx because it is the x component of current density. So we can write divergence of xj is equal to x divergence of j plus jx, implies that x divergence of j is equal to divergence of xj minus jx. यहाँ पे जो है हमने इस टर्म की वैल्यू को निकाला है, jx को हम दूसरी साइड पे ले गए हैं तो हमारे पास ये चीज़ आ गई। तो अब ये जो प्रीवियस स्लाइड के अंदर जो हमने x कंपोनेंट लिया, अब x कंपोनेंट में r की बजाय x है यहाँ पे, तो ये बन जाएगा डाइवर्जेंस ऑफ जे एक्स डीटा। तो हमने डाइवर्जेंस ऑफ जे एक्स की वैल्यू निकाली है, तो डाइवर्जेंस ऑफ जे एक्स की वैल्यू को हम यहाँ पे पुट कर देते हैं ताकि हम x कंपोनेंट को निकाल सकें। तो इस तरह से डाइवर्जेंस ऑफ इंटीग्रल डाइवर्जेंस ऑफ जे एक्स डीटा वुड बिकम इंटीग्रल डाइवर्जेंस ऑफ एक्स जे डीटा माइनस इंटीग्रल जे एक्स डीटा, एंड using the divergence theorem we can write what is the divergence theorem. Divergence theorem is actually the relation between the volume integral and surface integral. In this way, integral over the volume divergence of v deta is equal to closed surface integral over the v dot dA. And using this divergence theorem we can write this first term like this: integral divergence of xj deta is equal to integral xj dot dA. This is the surface integral, this is the volume integral. Here the function v is xj, so xj, here we take the divergence of v mean divergence of xj, here we take the dot product v dot dA mean xj dot dA. Put this value in this first term, and so we get integral divergence of jx deta is equal to integral xj dot dA minus j integral jx deta. Since j is entirely inside the volume v, it is 0 on the surface S of this volume v. j क्योंकि ये वॉल्यूम करंट डेंसिटी है और वॉल्यूम करंट डेंसिटी वॉल्यूम के अंदर नॉन ज़ीरो है, जबकि सरफेस के ऊपर वॉल्यूम करंट डेंसिटी की वैल्यू ज़ीरो होगी। ये चूँकि एक सरफेस इंटीग्रल है, जब हम इसको सरफेस के ऊपर एवेल्यूएट करेंगे तो j की वैल्यू सरफेस पर ज़ीरो है, तो इस तरह से हमारे पास j डॉट dA भी ज़ीरो होगा और ये पूरा होल इंटीग्रल ज़ीरो के बराबर हो जाएगा। सो वी पुट हेयर दिस फर्स्ट टर्म इक्वल टू ज़ीरो एंड देन वी विल गेट इंटीग्रल डाइवर्जेंस ऑफ jx डीटा इज इक्वल टू माइनस इंटीग्रल jx डीटा। Integral divergence of jx deta is equal to integral minus integral jx deta, which is the x component. Similarly, we can find out the y and z components. Y component is integral divergence of jy deta is equal to minus integral jy deta, and for z component, integral divergence of z deta is equal to minus integral jz deta. Combining all these x, y and z components, we get j vector here. Instead of jx, jy and jz, we get j vector here. And similarly, we get r here, and in this way the integral become divergence of j r deta is equal to minus integral j deta. So dp over dt is equal to integral curly rho over curly t r deta is equal to minus because we have put in the value of curly rho over curly t using the continuity equation here, and we get minus integral divergence of j r deta is equal to, and we have proved this integral is equal to integral g deta, and so dp over deta is equal to integral j deta, and hence proved.